Hi, this is Mr. Max. So I am doing the second part of the 2016 paper 4 extended. I said this paper can be used by learners who are also following the new syllabus, grade 10 and grade 11. So these questions start from 6 to 10. The first part was from question 1 to question 5. So the first one here is supposed to factorize here. You've got 4 terms, so you factorize by means of grouping. You can rearrange the terms if you want to, or unless you do what I do. I say 1 goes into a minus 3b. So I put my 1 here just to clarify. And then obviously here what's common is minus 2x. And then when I do write 1 minus 2x in its own bracket and 2a minus 3b in its own bracket, because 2a minus 3b is a common factor. Now, sometimes the 1 is not written, but you should know that it is there. It is a common factor. And the following one here as well, you've got 4 terms. Here, x squared is common. So if you take out x squared, you're left with y squared plus 1. And obviously 1 goes in here. And that is why I put plus 1, so that you can see how we get to x squared plus 1 and y squared plus 1. Right, so the B part, you have got algebraic fractions here. And you're supposed to subtract, and subtraction of fractions means you're supposed to look at the lowest common multiple. Then this is x squared minus 9. So this is the difference of two squares. X squared minus 9 is the same as x minus 3 in its own bracket and x plus 3 in its own bracket. All right, and now the lowest common multiple will simply be x minus 3, x plus 3. So the 5 here does not have that x plus 3. So you're saying basically you're going to multiply this whole fraction here by x plus 3. Now you must be careful when you multiply out here, since you're multiplying by a negative, and a negative changes a positive sign to a negative, for example. Okay, so when you clean this up, it's 2 minus 15 is negative 13. And the final answer should be minus 5x minus 13 over that denominator. It doesn't matter which one comes first, whether you put minus 13 minus 5x, still the same thing. Right, so here you have exponential equations. Now you're looking for x, and when you are looking for x as an index, it means you probably have to use indices, and if that doesn't work, you need to apply the laws or logarithms. Now, first of all, they put 2 times here, and sometimes it's not written like that. So most of the time, what you will have is you have a 2, and then you have a 3 here, and then x plus 5 here. All right, so the reason why they made this a little bit easy is so that you can realize that you are supposed to divide by that 2. All right, and a lot of learners, they go ahead and multiply that 2 over with the 3, and that does not make any sense at all. So first things first, you got to isolate the one containing the base with the x plus 5 power. You have to isolate that by dividing throughout by 2, as I show you here in blue. And then you clean that up, you obviously get 21.87. Now you cannot write 21.87 as a power of 3, making the bases the same, so you have to introduce logs. So I take logs on both sides, and then I use the power law to put the x plus 5 in front of the log, and all you have here is log 21.87 divided by log 3. And once you do that, you then subtract 5 from that particular answer, and you will get a negative answer here, and then you give your answer correct to 3 significant figures as negative 2,19. Right, here you have got an equation. Again, put brackets, very important, and try to make the whole denominators throughout the same. LCM x minus 2 and 4. Just combine them. I indicated with the colors, and then I clean up what I have in the numerator, and you can actually from this point onwards drop the denominators, because if something is out of something equals something out of the same something, if I can say that, these are equivalent fractions, then you can equate the numerators. Okay, so from there on, it's just to clean that up, multiply out your binomial here, and then remember, ultimately the equations, they should equal to 0 since it becomes quadratic. So I'm getting x squared minus 13x plus 30 equals to 0. And from this point, you can factorize two numbers, multiply, give you 30, add them, give you negative 13. The numbers happen to be negative 3 and negative 10. All right, and you equate everything to 0. X minus 3 is equal to 0. So that means x is equal to 3. X minus 10 is equal to 0. That means x is equal to 10. Right, here you have got log 2 equals a, log 3 equals b. So you are supposed to determine the value of log 12. So first of all, what you need to do is you write log 12 as 3 times 4, or you can write them as prime factor form. Okay, then now multiplying numbers means the same as adding logs, log 3 plus log 4. We already know what log 3 is, but the log 4 here can be written as 2 squared, and use the power law then to put our 2 in front, and I indicated here with blue. So I'm going to remove the blue part and replace them with the letters as b plus 2a. And this is how you essentially write this in terms of a and b. It means your answer should contain a and b, not logs anymore. Okay. Right, so what we have here is we are supposed to reflect this triangle A. And we need to draw the line y equals to 4, as I'm doing there. And what I put here is some valuable information. Every point on the image is the same distance, so you count. And then it's going to be the same distance where you're going to put that triangle B there. Okay, so make sure that the image is going to be a reflection. And this red line here acts as the mirror line. The size does not change, so it's going to be values, it's going to be reflected, and that is how this particular question is answered. Okay, so same distance, every point, this point of A, same distance away from the mirror line as the corresponding point here. This point of A here, the point that you have here, negative 2, okay, comma 1, is the same distance when you count up to the mirror line. All right, make sure you know your scales here. That's 1, 2, 3, then 1, 2, 3, its corresponding point. And that is how you find the image. And then you label it accordingly. Right, they want you to rotate this triangle, let's say through the origin. So I'm just going to bring in the origin. Now there's some interesting facts. So what I did here, because of a rotation of 180 degrees, means that the coordinates are the same, but it now depends on which quadrant will the triangle that is rotated be, the C triangle. So it's going to be in the 4th quadrant. So the x, y value, x is positive in the 4th quadrant, and y is negative in the 4th quadrant. So the only thing that needs to do is you just have to change the signs of the coordinates, like what I did here. So now x is positive, so this is going to be 2, negative 1, and 4, negative 1, and 4, negative 2. Same coordinates, just swapped around because of the quadrant in which this lies. There are also other methods. All right, so I have my 3 points here, and then I draw my triangle and I label it. So when I take a point and a corresponding point and I join them, they will all pass through the origin. Okay, and it will be straight lines that you are drawing. Right, so here we have the same question. We're supposed to describe the single transformation in full that maps triangle A onto E. Well, as you can see, the triangle has just been translated. Yes, it has just been sort of slided to the right and then upwards. So that's a translation, and it's translated by a given vector. So the top value of the vector is the x direction, and the vector, the component on the bottom of the vector is the y direction. So it's both positive. It means 8 units to the right. You can check by taking this point and look at this corresponding point, and then you can count. Make sure you understand the scales here, and you will see that you get exactly 8 units to the right that point has been slided or translated. And then when you look at the scale here for y, you must make sure that you get 1, 2, 3, 4, 5 units. All right, so that is the vector. The vector is 8, 5. Then you're also supposed to describe fully the single transformation that maps D onto A. D is the object, A is the image. So this is obviously an enlargement, but what happened here is it's going to have a scale factor that is a fraction. Okay, and how do you find that scale factor? Is you divide horizontal distances by horizontal distances. So make sure you can take, for example, this is 1, 2, 3, 4, 5, 6. 6 divided, or you take this distance here, 2 over 6. 2 over 6, which is going to give you 1/3. Okay, or you take vertical distances, and over vertical distances, so it's 2 over the same, that is going to be 1, 2, 3. So this is 1, 2 over 1, 2, 3, 4, 5, 6. Okay, all right, or just 1 unit here divided by 1, 2, 3 units. Bottom line, this scale factor should be a fraction. And when you join the lines, the corresponding points, by drawing lines here, the point where they meet, in this particular point, is negative 6, 0. That is the center of enlargement. And then you also have to write that down. 3 marks for such a question. Right, below is a table of values, and you look at this function is a discontinuous function. That means it has no values for x when x is 0, because you may not divide by 0. That is why this part is blocked out for you. All right, so you can only have x values in the negative sense up to closer to 0, and the other values closer to 0 and obviously going away from 0. So this particular graph, if you draw it, is going to be discontinuous. It's not going to be one continuous graph. Okay, right, so you need to find the missing value. So what I do and what I advise you to do is put brackets here, and the fact that you're squaring, whether it's a negative 1.5 or a positive 1.5, squaring gets you a positive answer. So S is about 1.333 recurring, but they say you must give your answer to 1 decimal place. T is equal to 12 once you do the same, and U is equal to 3. So again, it doesn't matter whether you use -1, the negative values, or the positive values, you're going to get the same outcome. Right, so we will use the graph paper, and we have to use the scale to represent this particular function. So what I do on the next slide is where I actually have the graph paper. So I followed the instructions as to what I should do. Now I'm going to bring back my table. I'm first going to take the negative sides. So -2, I get 0.8. Negative 1.5, I get 1.3. Negative 1, I get 3. Negative 0.5 gives me 12. So obviously, I can plot those points, and then I can draw the curve. And I'm going to do the same when I get the positive values of x. Remember, the line x equals to 0 is the y-axis, so this graph should not cut the y-axis. It doesn't do that. It discontinues because it doesn't have a value when x is equal to 0. And the y-axis is actually x is equal to 0. All right. So now that I have the right side, I can also plot the points, and then I can draw the function. That's worth 5 marks doing that. Plot each of the points, make sure all the points are plotted, and it should be a smooth curve. Right, we're supposed to use the graph to solve the following equation. Now, this function is this graph that we have here, this continuous function here. And if it's equal to 8, this is y equals to 8, because this is on the side of the y. So I would start by drawing the line y equals to 8. And where that line cuts the function, I'm going to read the 2x values. And to read off the 2x values, I'll suggest that you know what does one little square represent. So on the x-axis, one little square, so if you take 0.5 and you divide it by 10, because there are little 10 blocks in there, you should get 0.05. So if you have to count from 0 how many blocks you have, right? So that's like 10, 11, 12, 13. So once you do that 13 times 0.05, for example, I know that I'm getting like a negative 0.65, which is what is indicated here, for example. Okay, and then the other side, obviously, you should get 0.65. So that is 0.65 is right up there. All right, so make sure you understand your scale, and also make sure that you use your ruler to find those values where the function meets the line y equals to 8. All right, so now here they're saying use your graph to solve this equation. So it's the function equals to 2x plus 6. Then 2x plus 6 is a line. So let's draw the line y equals to 2x plus 6. But before it, I need to make a table. So I did a table here where I take values of x, the extreme values that I get from my domain, that is negative 2 and 2. So once I plug in negative 2 into the function, I get a 2. Once I plug a 2 in here, I get 10. That's 2 times 2 plus 6. So this point here is a point on the Cartesian coordinate system, negative 2, 2, as you can see. I plotted here. The other point, 2, 10, is also a point all the way up there. And then you draw the line. Okay, and once you draw the line, now you read off where the line cuts the curve, and you read off the x values. Well, mine is somewhere in the region of x equals to negative 0.9 and x equals to 0.7, but they accept anything in the range of x is equal to negative 0.85 or x is equal to 0.65, adding plus minus 0.2 to your answer. That means you can be out by 0.2. Right, now they want us to draw a suitable tangent. This is just an estimation at x equals to 1.5. So what I did is I borrowed something from A-level or higher level mathematics. If you have these calculators that can differentiate the function, I just do that because it gives me an idea what the gradient should be. But what you need to do is you need to draw yourselves a line that touches that particular point, and I use that point, for example, when I do my gradient, and the line goes in the negative direction, so the gradient will be negative. Okay, so I get about 2.6 where the line cuts here, and obviously this is the point 1.5. And when I divide the two, I get negative 1.7. So anything in the region between negative 2 and negative 1.8 will be accepted because it all depends on the smoothness of your curve. Right, question 9, the boundary of a park is in the shape of a triangle, as you can see below. Now they are saying the scale is 1 centimeter, represents 20 meters. So that means that 120 meters is going to be 6 centimeters here, if I convert it. And 180 meters is going to be 9 centimeters. And 260 meters is going to represent 13 centimeters, if I follow that scale, because I'm going to draw this particular triangle. So I'll show you on the next slide what I did. Right, so my distance from A to B is 13, and the distance from A to C is 6, and the distance from B to C is 9. So what you do is you use your compass and your ruler, okay? You open a radius here of 6 centimeters, essentially, and you do the same here, radius of 9 centimeters. And where they intersect, all right, after the first thing you do, obviously you draw the horizontal line that is 20 centimeters long, and where they intersect, that's going to be the point C there. But all of these things must be done on the same triangle. I'm just doing step by step. Then use a straight edge and compass only construct a bisector of angle ACB. So you need to cut that angle in half. And I hope that you guys have done how to bisect an angle. So you obviously take your compass and then you find points where they intersect, and then you draw the line. And this is basically what you need to use. Obviously you need to use your compass and your ruler to do this particular stuff. All right, so you need to bisect that angle, and if you do that, but remember you do everything on the same diagram. Okay, so just remember, very important, sometimes this question is given to you. They say construct the loci, which is equidistance from CA and CB. You can see these are two lines, CA and CB, so it means angle C needs to be bisected. To bisect means to cut in half. The third part says you must use a straight edge and compass to construct the locus of points inside the triangle which are equidistant from B and C. That simply means you must draw the perpendicular bisector of B and C. And I hope you still know how to do that. So you've got a line here, and you obviously draw yourselves an arc, open the radius slightly more than half the distance between line B and C, and then you're going to do the same on both sides. Where they intersect, you draw yourselves that line here. So I've used the software, and obviously it's this particular line here, the green one. Right. Flowers are planted in the park so that they are nearer to C and to B. Now see, I brought a triangle back with everything that I needed to do. So we need to do a few things step by step here. So let's identify the region that must be shaded. It's 1 mark, and don't waste your time in examination if you can't find the shading. For 1 mark, rather focus on finishing the rest of the paper and come back then. But it says nearer to C and B. So anything nearer to C and B, so this perpendicular bisector comes into play. So the part I must shade is either this region here or this region here, okay? Because anything here is nearer to C than to B. But then it's not done. It says nearer to AC than BC. And because it says AC, I know my shading must take place on AC. All right, so the region that will be shaded is this particular region, and this blue line, the bisector, the angle bisector, is acting as the border. All right, so this is where the flowers needs to be planted. So when it says you are supposed to shade nearer to AC, then you should know your shading should take place exactly. It should touch AC like what you have here. So it touches the line AC and it should not touch the line BC. Okay, so this is where the shading is supposed to take place. And I repeat, this is just 1 mark. Do not waste your time too much in the examination. Come back later on if you haven't mastered this part of shading, but it's really straightforward business anyway. Right, now we use trigonometry, not the stuff in part B. So I brought the triangle back, and we're supposed to show that this angle ACB is equal to 118. So that is the cosine of angle ACB. And I hope you still remember your laws of cosine and your laws of sine, because they come in handy here. So what you have is 120 squared plus 180 squared minus 260 squared all over 2 times 120 times 180. So you get where cosine is negative, telling us that that answer or that particular angle has to be an obtuse angle. All right, so finding the inverse of cos the arc angle, so that's going to be use your calculator. And obviously when you use your calculator, please make sure that your calculator is in degree mode. There should be a DEG displayed on your calculator, or a D depending on the mode or the type of calculator you have. Now we should calculate the area of the park, so we just use our formula. The area of any triangle, half times 120 times 180. Then you multiply that by the sine of the angle that is being flanked by the two sides, okay? And once you do that, you then give your answer correct then to 3 significant figures, which is 9,460 square meters. Now they ask us to calculate angle BAC, so the sine rule comes into effect, okay? Sine of angle BAC over 180. That is, remember, you need a complete pair in order for you to use the sine ratio. So since we know this is 118,8 degrees, this here is a full pair. And once we have a full pair, right, we can actually calculate the missing angle that we are looking for. And the missing angle we look for is obviously going to be here. That's why I'm comparing these sides with each other. And then multiply by 180, you clean this up, you get some decimal value, and once you get that value, remember you're looking for the angle, so you need to find the inverse sine of that angle. Again, I cannot reiterate it more that your calculator should be in degree mode, and you should get 37.3 degrees correct to 1 decimal place. Question 10, you're supposed to make y the subject of the formula. Now, please don't forget to subscribe to my channel and also click the notification bar, all right, in order for you to get notifications every time I post videos. I'm going to do quite a few of these, helping you prepare for examinations and so on. Right, so first of all, y square equals x plus 1. So what I did here is I take square both sides. A square ultimately sort of undoes. So when the square root, so if you take square here and you square here, the square root and the square are reverse operations of each other. Okay, and obviously now the only thing left is for you to subtract 1 from both sides, and then you have y squared minus 1, and that is what the x value is when you make x the subject of the formula. Part B, you must solve these two equations simultaneously. It's a 6-mark question. So you have x times y is equal to 20. So take the second equation and make x the subject of the equation, because you only solve this by substitution method. So it's best if you can make something the subject of the formula, and the wise one here is to make x the subject of the formula, because if you make y the subject of the formula, you're supposed to go divide by that -2 and you end up with fractions. Alright, so this equation is x equals to 2y minus 3. It's actually the same as the above equation. You take this x value, you substitute it into the first equation, xy equals to 20. Okay, and once you do that, you will actually be calculating the value of y. Now, if you realize, we're going to end up with a quadratic equation. So we look for two numbers, and you can use completing the formula, or just using completing the square, or using the quadratic equation formula, but this factorizes. Two numbers multiplied to give you -20, and the number is -8 and 5. And if you add them, give you -3. All right. So we then simply deduce the left side of the equation can be factorized nicely, and you have 2y and y minus 4 plus 5, y minus 4. Since y minus 4 is common, you write it once, and everything outside comes in the bracket. So now it's easy. You let h1 equals to 0, and you solve for 2y equals to -5. That means my y value is going to be -2.5, and the other y value is y equals to 4. So now we need to find the corresponding x values. So to do that, you can use this equation where you make x the subject of the formula. It doesn't really matter. All right. So this is the best one to use. So I'm going to put in when x or y is -2.5, I get an x value of -8, and you put it in the right place. When x is 4, I get 5 as an output, so you also put it at the right place. So this is about half an hour worth of work. I went through it a bit faster, but you have the beauty of pausing the video and making sure that you follow it, and try to attempt the questions on your own. If you have the question paper, it's even going to be very beneficial.